Okay, in this example, we're talking about the probability of at least one. Okay, now right here is the rule of complementary events. The probability of A equals 1 minus the probability of A complement. And that's an important concept in probability. And we do actually have a video corresponding to the rule of complementary events. But now we're talking about something more specific. If A is the event of the phrase at least one, then a complement would be none. For example, if you're talking about a coin flip, flipping a coin 3 times and talking about the probability of it landing on heads at least once. Either it's going to land on heads at least once, either once or twice or 3 times, or none at all. Those two things are complements. In other words, the phrase at least one is the complement of none. And we're going to use this equation right here to solve this particular problem. So again, this is very important to remember. P of at least one is 1 minus P of none. Okay, so here's our problem. Suppose a coin is flipped 3 times. What is the probability it will land on heads at least once? Okay, now this is a typical example, flipping a coin. And there are other ways to do it. You could literally write out the entire sample space. You could get heads, 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 tails, heads, and then just keep on listing all the different possibilities. That's one way of going about it. But for this particular example, because we want to stress the concept of the probability of at least one, which is an important concept that extends to more than just this particular example, we're going to do it a different way. We're not going to list the entire sample space. We're going to use that equation right there. Okay, so to use this equation, we first have to calculate the probability of getting no heads, the probability that will not land on heads any of the 3 flips. Okay, so we're going to find the probability of none, which I'm just writing no heads. I very well could have written P of none. Okay, so P of none is the probability of the first not being head times the probability of the second one not being heads times the probability of the third one not being head. And here we're using the multiplication rule. 1/2 is the probability the first flip will not land on head. 1/2 is also the probability the second flip will not land on heads. 1/2 is also the probability the third flip will not land on heads, because it's either going to land on heads or tails. So the probability it will not land on heads 3 straight times is 1/2 times 1/2 times 1/2, which is 1/8. Here we're just multiplying fractions together. The numerator is 1 times 1 times 1 is 1. The denominator is 2 times 2 times 2 is 8. So that's the probability of flipping a coin 3 times and not getting heads at all. Probability of no heads. So now to finish the problem, P of at least one is going to be 1 minus P of none, which we just found out. So P of at least one is going to be 1 minus 1/8. And if you make that calculation, 1 minus 1/8 will give you 7/8. So the probability of flipping a coin and having it land on heads at least once is 7/8, whether it be the first flip, the second flip, the third flip, all 3 flips, whatever it may be, the probability of getting at least 1 heads is 7 out of 8. And we solved this problem using the very important concept, which is written over here, which is P of at least one is 1 minus P of none. That's a very important concept that you have to be aware of.